Today we're going to have a teaching exercise to learn how to make the world's simplest copper induction rotor. What I've got here is a motor, a copper induction motor on 3-phase power, U, V, and W, 3 wires coming out here, and they go to this power supply of variable frequency. I can turn the dial and get any frequency you want, which is proportional to voltage. So 0 hertz is 0 volts and 50 hertz is 240 volts. So you can get the field to rotate any speed and voltage you want. Then I have a wooden stick here, a little 8mm wooden dowel. And here's the copper induction rotor, which is the world's easiest. And the way it works is, we just have a stack of steel bearings here, and the next layer is a bunch of double-sided mirror tape to whatever thickness you want. Then around the outside we take some copper bars about 15mm wide, 3mm thick. And the fourth part, we take a little copper foil and just wrap it around the ends, and that lets the currents flow from bar to bar. So now we're going to take the device, simple little homemade device, and put it on the stick where it can spin by hand. Next we're going to put it into the rotor like that, and it doesn't spin, but now when we turn on the 3-phase power, the magnetic field starts rotating around 12 times per second, and so does the rotor. This is due to Lenz's law currents both in the bearings and in the copper, as I'll explain in a minute. Let's go to 20 times per second. And now it's spinning at 20 times per second. So, now we've taken the mystery out of the physics. Let's explain how to make it and how the physics works. Now the first thing I'm going to show you, I've got 4 bearings here, 8mm bearings, made of carbon steel, and they're also magnetic, so they'll pick up a field and they'll spin by Lenz's law as well. So I'm going to put these little 4 bearings on the stick just to get started with. Put them on the stick, slide them on, and just the bearings by themselves, they can spin. Let's put them in the machine and see what happens. We just put them in there to begin with. Now let's turn on the power. Lo and behold, the bearings spin, and they're spinning at 12 times per second. What's happening is the rotating magnetic field is making the iron magnetic in a rotating sense, and also it's inducing currents in the carbon steel, and they're spinning by Lenz's law, sort of weakly in the very center. And they'll also spin very fast if we want them to. So this is essential. The center of your device has to have this little part to get it spinning to begin with. The next step, this is for teaching purposes, is just to take some double-sided mirror tape and wrap it around the bearings like this. Take off the paper. Just wrap it around the bearings like that. And you put another piece here. And just wrap it around the bearings. And you can keep doing that in layers until the first layer, you keep doing that in layers until you get any desired thickness you want. Now we have the bearings in here and we have the mirror tape wrapped around any thickness we want. The next step is to take some copper bars and just paste them around smoothly around the outside like this. And you can cut these bars. Here I have 5 of them, just any way you want. And what you can do is you can cut these quite easily from a sheet of copper with a hacksaw like that. And now we have 5 bars around the outside of the device. For a larger radius it might be 7. Just put however many it takes to fit. Now the final step is to get some copper foil about 0.3mm thick. And we cut 2 strips of that. And on each end of the copper bars we just wrap the foil around over the bars like this. And the reason we're doing that is we want the current to be able to flow from one bar to the next when it runs to the machine. Current will go like that and like that. Now I've wrapped copper foil on both ends of this device. We have one wrapped here with tape, and here's some more copper foil sitting over these bars here. And what we do next is just take some yellow tape and wrap it around tightly here to hold everything together. And there we have our copper induction rotor. You can put more tape if you want. Now the way this device works in terms of physics, we have some bearings in the middle here made of carbon steel, and when they go into the device, they pick up the rotating magnetic field from the coils, and they'll start spinning around by themselves, as I showed earlier, to get the center of the part of the device going. Now the copper bars will be on the outside near these coils, and they'll also pick up currents which will go up and down as the device rotates, and they'll go through the copper foil from one bar to the next. And these will also be dragged along by Lenz's law. As the field rotates that way, the copper and iron will both rotate in the same direction. So let's turn it on now, put some speed, and watch how it works. So here we have the world's simplest copper induction rotor. We have a stack of bearings here, mirror tape making a desired thickness, and then a bunch of copper bars on the outside joined by foil into the yellow tape. And we're going to put this on a wooden dowel, 8 millimeters diameter, and we're going to put it into the machine. Now when we turn on the power, you can see it starts spinning at low power. Now what I'm going to do for this demonstration, I'm going to put a piece of plastic over it so we can spin a little faster and more safely. So there it is spinning at low power, medium power about 20 hertz, and that's about 30 hertz. And it spins quite nicely. So in summary, although nobody's going to use this in a real device, you can use this as a teaching exercise to teach your students how to make a copper induction rotor and what the physics are. We get Lenz law currents both in the iron and the copper, and they both spin with this rotating magnetic field.